Hi everyone in Algebra 2B. Today we're going to be going over your questions for lesson 112, part B, starting on number 16. So number 16 says find the number that is 1/3 of the way from 2 1/8 to 5. So I am going to start by filling in the equation, which is n is equal to the first number plus the fraction times the second number minus the first. This is the fraction, this is first and the second. So the first is going to be 2 1/8. The fraction is 1/3. The second is 5 minus 2 1/8. We're going to make these into improper fractions. So that would be 17/8. I'm going to put this one over 8 too, so that would be 40/8 minus 17/8. So we have 40 minus 17, be 23. So that would be 17/8 plus 1/3 times 23/8. We're going to make a common denominator here. Should end up being 24. So 17 times 3, give me 51. So it'll be 51/24 plus 23/24. So add 23 to that, you get 74/24. That could be simplified by 2, so that would be 37/12. And that would be your result. So all we had to do was make those into improper fractions, then just follow the equation. Number 5, we're asked to solve this by quadratic formula. So I'm going to set this equal to 0. That would be 0 is equal to 5x squared plus x plus 4. And now I have my a is going to be 5. My b is 1 and my c is 4. So I have x is equal to -1 plus or minus the square root. 1 squared minus 4 times 5 times 4 all over 2 times 5. So -1 plus or minus the square root of 1 minus 4 times 5 times 4 would be 80 all over 10. Now I can separate that, so that would be -1/10 plus or minus the square root of 79i over 10. And that is it. So we solved that by quadratic formula. Solve that by quadratic formula. Now for number 18, the first thing I need to do is we're going to be solving for the equation, because we're trying to find the equation line that's perpendicular to this line but goes through this point. So I have -3y equals -x plus 4. Divide everything by -3 would give me y is equal to 1/3 x minus 4/3. Now, if I'm trying to find the perpendicular of this line, I'm going to take the negative reciprocal of the slope, which is this. So that means you flip it and make it negative. So that would be -3x plus b. Plug in our point. So we have -7 equals -3 times 5 plus b. I'm going to add 15. I'm going to have 8 equals b. So my equation, my perpendicular line is going to be y equals negative 3x plus 8. And I might have written that problem down wrong because that's definitely not what the answer key says, because it says this is positive. So this x must have been negative in the original problem, but since I messed up writing it down, you can just leave it that way. Okay, so now moving on, let's look at number 19. So number 18, your answer is going to be different from the answer key. But I think that mine's, oh, the 3 was supposed to be positive. Okay, anyways, I'm going to multiply this by 4. Multiply the bottom equation by 100. Top equation is going to become 2x plus y equals 28. Bottom equation is going to become 70x minus 2y equals 536. You can do substitution or elimination. I'm going to do elimination by multiplying this by 2. That would give me 4x plus 2y equals 56. When I add those two equations together, I'm going to get 74x is equal to 56 plus 536, and that gives me 592. And then divide by 74, so x is equal to 8. Now I want to solve for y by using this top equation. So it would be 2 times 8 plus y equals 28. 2 times 8 is 16, so I'm going to subtract 16 from both sides, which means that y is going to be equal to 12. So 8, 12. Now looking at number 20, I'm going to start by solving for one of the letters, and probably the easiest one to solve for would be the x in the top equation. So x would be equal to 2y plus 10. I want to substitute that into this equation, so that would be 3 times 2y plus 10 minus c equals 11. So that would be 6y plus 30 minus c equals 11. Subtract the 30, which would give us 6y minus c equals negative 19. Now I have two equations. I have this y and this y. So let's multiply this top one by negative 3, which would give us negative 6y plus 9z is equal to positive 27. Now our y's will cancel, and we have 8z is equal to 8. So therefore z is equal to 1. Once you know that, you can solve for y. We can plug it into this equation here. So that would be 6y minus 1 equals negative 19. Move the 1 to the other side, so you get 6y is equal to negative 18. So therefore y is equal to negative 3. Then to solve for x, I'm going to plug it into the top equation. So that would be x equals 2 times negative 3 plus 10 would be x is equal to negative 6 plus 10. So x is equal to 4. So x is 4, y is -3, and z is 1. Now looking at number 21, I'm actually going to solve the top equation for y, moving the y to the right and the 7 to the left. So it would be 2x minus 7 equals y. So it would be x times 2x minus 7 equals 4. If I multiply this through, move the 4 to the other side, I get 2x squared minus 7x minus 4 equals 0. And we can solve this by either doing a quadratic formula, or we could actually solve using our equations that we just learned. So let's do that. Let's try it. So if I do first step, 2 times -4 gives me -8. Now two numbers that multiply to give me -8 but add up to give me -7 would be -8 and +1. They add up to give me -7. So the -8 and the 1 will replace your -7x. So you get 2x squared minus 8x plus 1x minus 4 equals 0. I'm going to put this together and this together. So 2x squared minus 8x, and then plus x minus 4. So we can factor out a 2 and an x from the left side, which will leave me with x minus 4. We can factor out a 1 because that's the only thing you can factor out of the right, which means that you have a common x minus 4. So that means I'll have x minus 4 times 2x plus 1 equals 0. But you have to solve for x. So I'll have x minus 4 equals 0, and then 2x plus 1 equals 0. So my first answer is going to be x is equal to 4. My second answer, 2x would be equal to -1, so x would be equal to -1/2. And now I have to solve for y for each. So if x is equal to 4, I have 2 times 4 minus 7, equals y. So 8 minus 7 is 1. So my answer would be 4, 1. X is 4, y is 1. Now the second one, I would do 2 times -1/2 minus 7 equals y. 2 times -1/2 is -1. So my answer would be -1/2, -8. So that one, we didn't use quadratic formula and we didn't use completing the square. We actually used our new pieces that we learned. I think it was in lesson 105. Okay, so now moving on to number 22, we actually see that if we add those top two equations together, the y's would cancel. So that's what we want to do, is just add those two together. That would give me 3x plus 2z equals -4. If I add the bottom two equations together, the y's would also cancel. So I would have 5x plus 2z equals 0. Now I'm going to do elimination. So I'm going to multiply the top one by -1, leave the bottom one the same. So I have -3x minus 2z equals 4. Adding that to 5x plus 2z equals 0. So the z's are going to cancel. You end up with 2x is equal to 4. So therefore, x is going to be equal to 2. Now to solve for z, I'm going to plug back into the top equation. So I would have 5, or the bottom, 5 times 2 plus 2z equals 0. When you move the 10 to the other side, it's going to become negative. So 2z equals negative 10. So z is going to be equal to negative 5. Now lastly, we have to solve for y, which you can plug into any of the equations. I'm just going to plug into the top equation. So I have x, which is 2, plus y plus negative 5 equals 1. And 2 minus 5 would be negative 3. So y is going to be equal to 4. So it would be 2, 4, negative 5 for number 22. Now looking at number 23, we're going to simplify. I squared is equal to negative 1. I cubed is negative I. So this will turn into 3 plus 2i. Square root of negative 3 times square root of negative 3, because it's exactly the same, would be just negative 3. And then the square root of 9 would be minus 3i. Square root of 9 is 3, and then because of the negative sign, you put an I. So we're going to multiply top and bottom by the conjugate, which is going to be negative 3 plus 3i. You only change one of the signs. 3 times negative 3 is negative 9. 3 times 3i is going to be 9i. 2i times negative 3 would be negative 6i. And then 2i times 3i would be plus 6 times negative 1 over negative 3 times negative 3 is 9. Negative 3 times 3i would be negative 9i. Negative 3i times negative 3 would be plus 9i. And then negative 3i times positive 3i would be negative 9 times negative 1. So the 9i should cancel. In the numerator, I have negative 9 and negative 6, which would give me negative 15 plus 3i, because 9i minus 6i. And in the denominator, I'm going to have 9 plus 9, which is 18. So all of that right there is divisible by 3. So I would do negative 5 plus I over 6. And you can separate that into two separate fractions if you would have liked. Now looking at number 24, I'm going to start by distributing this 1/2. So I have a to the x over 2 minus 1, y to the 2, y to the negative x over 2, and a to the negative x over 2. And now we're going to add the a's together and the y's together. So that would be a to the x over 2 minus 1 minus x over 2, and then y to the 2 minus x over 2. So what you should recognize on that problem is that the x over 2's are actually going to cancel in here, and you are just left with a to the negative 1 and then y to the 2 minus x over 2. And that whole thing right there would be your result for number 24. Now looking at number 25, we're going to change this from radical form into exponential form. So I'm going to change this to x5y to the power of 1/3. And then x5y squared would be to the power of 1/2. You're going to distribute this to the exponent. So that's going to be x to the 5 over 3, y to the 1 over 3, and then x to the 5 over 2, and then y to the 1. You're going to add the x's, add the y's. So that would be x to the 5 over 3 plus 5 over 2. and then y to the 1 over 3 plus 1. You need a common denominator, which would give you x to the power of 10 plus 15 would be 25 over 6. And then for y, it would be 1 over 3 plus 3 over 3, which would just be 4 over 3. So your result is x to the 25 over 6 and y to the 4 over 3. Now looking at number 26, to get rid of the square root in the denominator, I'm going to multiply top and bottom by that square root. And simplify the square root, so that would be 2, and then 28, and then 2 and 14. So this would be the square root of 14 over 7 plus the square root of 14 over 2 minus 6 square root of 14 over 1. The common denominator is going to be 14, so I'm going to multiply top and bottom by 14, then top and bottom by 7, and top and bottom by 2. So that would be 2 root 14 plus 7 root 14 minus, so 6 times 14 would be 84 root 14 all over 14. So I have 2 plus 7 minus 84, which will give you negative 75 root 14 over 14. Now looking at number 27, we have to get rid of that square root in the denominator by multiplying top and bottom by the conjugate. And I'm just going to flip one of the signs. So I'm going to make this 7 root 2 plus 3. And multiply this through. So I have 3 root 2 times 7 root 2. It's going to be 21 times 2. 3 root 2 times 3 would be 9 root 2. Negative 2 times 7 root 2 would be negative 14 root 2. Negative 2 times 3 would be negative 6. Bottom, 7 root 2 times 7 root 2 would be 49 times 2. 7 root 2 times 3 would be 21 root 2. Negative 3 times 7 root 2 would be negative 21 root 2. Negative 3 times 3 would be negative 9. So I have 21 times 2 minus 6 would be 36 minus 5 root 2 over 49 times 2, and then minus 9 would be 89. And that actually concludes your problem. There is no other simplification that can take place on number 27. Now looking at number 28, the first thing that I'm going to do is going to move the 2x to the other side. Also factor out an x from each of those equations. So it would be 3x squared plus 5x plus 2 equals 0. So I'm going to multiply the first times the last term, so 3 times 2 equals 6. And now I need two numbers that multiply to give me 6, but add up to give me 5. And actually, it's the ones that I just did. So 3 times 2 multiplies to give me 6. They add up to give me 5. Which means that I have x times 3x squared plus 3x plus 2x plus 2 equals 0. These would be two separate parentheses, leaving the x on the outside. You get 3x squared plus 3x plus 2x plus 2. What can I factor out of this parenthesis and what can I factor out of the second? In the first, I can factor out a 3 and an x, leaving me with x plus 1. In the second, I can factor out a 2, leaving me with x plus 1. Now, for step 5, I have the x on the outside, but then I'm going to take out this x plus 1. And what's left is 3x plus 2. So I have 3 separate equations that I have to solve for. I'm going to set x equal to 0 for the first one, x plus 1 equal to 0, and 3x plus 2 equals 0. This one I move the 1 to the other side. So when I move the 2 to the other side. So I have 3 answers. I'm going to have x is equal to 0, negative 1, and negative 2/3. So don't forget to solve after you're done factoring. Now number 29, same thing, we have to set everything equal to 0. So I'm going to move everything over to the right hand side. So 0 equals 2x squared minus 3x minus 2. Multiply the first number times the last number. So 2 times negative 2 is negative 4. I need two numbers that multiply to give me negative 4 but add up to give me negative 3. And that would be negative 4 and 1. That adds up to negative 3. So this is going to replace my negative 3. So 2x squared minus 4x plus 1x minus 2 equals 0. These are my two separate parentheses. So I have 2x squared minus 4x plus x minus 2. First parentheses, there's a 2 and an x to factor out, leaving me with x minus 2. Second parentheses, there is nothing to factor out, so you just do 1. And now you see a common x minus 2. So that would be x minus 2 times what's left, which would be 2x plus 1. And now to solve, you're going to set each of these equal to 0. So I have x minus 2 equals 0, and then I have 2x plus 1 equals 0. Move the 1 to the other side, so you have 2x is equal to negative 1. So your answers are going to be x is equal to 2 and x is equal to negative 1/2. And now lastly, number 30, same exact steps as we've been doing for every single problem. So step 1 is going to be 3 times 4. Gives me 12. Need two numbers that multiply to give me 12 but add up to give me 8. Those two variables are going to be 6 and 2 because they multiply to give me 12 but add up to give me 8. So the 6 and the 2 are what's going to replace my 8x. So I would have 3x squared plus 6x plus 2x plus 4 equals 0. First two variables, second two variables into parentheses. So 3x squared plus 6x plus 2x plus 4 You can factor out a 3 and an x from the first parenthesis, leaving me with x plus 2. Second parenthesis, you can factor out a 2 as well, and that would be x plus 2. Now you take out the common parenthesis, which would be x plus 2, and you multiply it by what's left, which would be 3x plus 2. Now you're going to set each of these equal to 0 to solve. So x plus 2 equals 0, and then 3x plus 2 equals 0. Move the 2 to the other side, would give you 3x is equal to negative 2. So my two answers are going to be x is equal to negative 2, and then x is equal to negative 2/3. And that should conclude all of your questions from lesson 112B. I hope you guys all have a great day. Bye.